here is what example 1 on page 488 said. The two major college entrance exams that a majority of colleges accept for admission are the SAT and the ACT. ACT looked at historical records and established 22 as the minimum ACT math score for a student to be considered prepared for college mathematics. And being prepared is defined to be a 75% probability of successfully completing college algebra in college. An official with the Illinois State Department of Education wonders whether less than half of the students in her state are prepared for college algebra. She obtains a simple random sample of 500 records of students who have taken the ACT and finds that 219 are prepared for college mathematics. In other words, they scored at least 22 on the ACT math test. Does this represent significant evidence that less than half of Illinois students are prepared for college mathematics upon graduation for a high school? Use alpha equals 0.05 level significance. Okay. So, what's the test? What's the H0 and the H1 here? Well, the person from the Illinois Department of Education thinks that less than half are ready, so she's looking for evidence to show that P is less than 0.5, and so we're going to assume that P is equal to 0.5. So there's our H0 and our H1, which we practiced finding in Chapter 10, Section 1. So, to perform this hypothesis test, these three things make up the criteria that have to be satisfied. We talked last time about how they're met. The problem told us we had a simple random sample. We checked in P0 times 1 minus P0, and remember that we said that P0 was the P that's tied to H0, so it's 0.5, and our N was 500, so we took 500 times 0.5 times 1 minus 0.5, and what did we end up with there? 125, I think it was, which is certainly greater than or equal to 10. And I told you that this last one's pretty much always going to be met. 500 is less than or equal to 0.05 times the number of high school students in the state of Illinois. So we're not going to worry too much about that one. So all three conditions are met, so I can perform the hypothesis test. As per your notes, step 1 in the hypothesis test is the H0 and H1. We've got that done. Step 2 is to set the level of significance. Michael Sullivan did that for us. He said test it at alpha equals 0.05. Now, remember what alpha is. It's the probability of making a type 1 error. So we're saying that we only want a 5% probability of rejecting H0 when H0 is true. Okay? And it's also going to be the area in the tails here in a few moments. If you look in your notes, step 3 says to get the test statistic. The test statistic for this test, the 1 prop Z test, is by definition P hat minus P0 over the square root of P0 times 1 minus P0 all over N. P hat, as we've seen earlier in the course, is the sample proportion. Our sample had 219 prepared to take college math out of a sample of 500. Your book calls that X over N. The number of individuals with the characteristic over the number in the sample. And if you divide 219 by 500, you're going to get 0.438. And everything else is as it was. P0's 0.5 and N is 500. And if you crunch the numbers there, you'll get negative 2.77. And remember that value is called the test value or the test statistic. And those two terms are used interchangeably. If you're the real math nerd here and you want to know what that represents, this represents the number of standard deviations that our sample proportion is from the mean.
Of the sample proportions?
Of the distribution of sample proportions, yes. Okay, now what do we do with that? Steps 1, 2, and 3 are the same, whether we're using the classical approach or the p-value approach. So let's talk through the classical approach there. Now, last time we talked about on your notes, the classical approach, I stated in your notes, says we measure how many standard deviations the sample mean is from the mean stated in the null hypothesis. That's what we just did when we found this test value. We're 2.77 standard deviations below. Right here. Ooh, right here. Okay? If the sample mean is if the sample proportion is too many standard deviations away, we reject the null hypothesis. So how do we determine if 2.77 standard deviations below the mean is too far away or not? Well, let's look at how the classical approach does that. The first thing we do with the classical approach is we find the critical value and shade the critical region. Well, let's go ahead and put that in our notes, but we're going to have to talk about what the critical value is. By the way, this parenthesis was put in the wrong place. Okay, so to find the critical value, we look at our alpha. We're going to put alpha in the tail always, and then find the z-score that goes with it. So, if we're going to put alpha in the tail, and this is, remember, this particular test is a what kind of test here? It's a left tail test. P is less than 0.05. Then alpha is going to go in the left tail. If it's a right tail test, we'd put it in the right tail. If it's a two-tail test, we'd split it up and put it in both tails. Okay? But here it's left tail test. So we're going to put alpha in the left tail. So we're going to put 0.05 over here in the left tail. And we're going to find the z-score that goes with the left tail area of 0.05. That's a chapter 7 problem. It's an inverse norm. That's right, Jenny. So we're going to inverse norm. Is this the one where we go 0.05 or 1 minus 0.05? 0.05, because inverse norm understands left tail areas. So take your calculator and inverse norm 0.05, and when you do, you should get negative 1.64. That negative 1.64 is called the critical value, as we said. And this area back here is called the critical region or the shaded region. Okay, so step 4 is done now. As far as the classical approach is concerned, we have found the critical value. Now, step 5 is, do we reject H0 or do we not reject H0? And the answer to that question is real simple. It's answered by what we have labeled up here as number 2. We ask a simple question. Is the test value in the shaded region? Well, the test value was negative 2.77, this value here. So the question is negative 2.77 in the shaded region? And clearly, it's easy to see here that it would be to the left of negative 1.64. It'd be back here somewhere. So yes, it is in the shaded region. So guess what? We reject H naught. Now, if the problem simply asks you to perform the hypothesis test using the classical method, we'd be done here. Because that's what we're always after. Do we reject H naught or do we not reject H naught? If the problem asks you for a conclusion, then we have to go back and think about what we learned in section 1 about what the conclusion is. And remember, the conclusion is always either there is significant evidence to show H1 or there's not sufficient evidence to show H1. Well, if we reject H naught, in this case, there is sufficient evidence to show, and I'm going to put whatever H1 is next. Well, H1 is that P was less than 0.5. And in the context of this problem, that means less than half are prepared for college mathematics. And then usually in your conclusion, you like to put what the level of significance was that you tested at. So we'll put at alpha equals 0.05. We didn't do that part in section 1 because we hadn't talked about the level of significance yet. So there is sufficient evidence to show less than half of Illinois high school graduates are prepared for college mathematics. And we didn't say that that's definitively true. We just said the evidence is pointing us that direction. The only way we know that it's true is if we went and took the whole population. That's the classical approach. Okay? Now, if it says to use the p-value approach, then everything we did in steps 1, 2, and 3, everything down to here would be the same. Okay? It's the same either way. It's only at step 4 do we do something different. And by the way, let me just say up front, the p-value approach should always give you the same result. You would never use the classical approach and say we reject H naught, and then use the p-value approach and do not reject H naught. They're going to give you the same result every time, as long as you use the same alpha. Okay? But they go about it a different way. So let's look at what the p-value approach does. So the big picture idea behind the p-value approach is we find the probability, and we know probability now means area in our class, associated with the test value. This is called the p-value. Okay, well, once we get the p-value, it's a real simple question then that we ask. We compare p to alpha. If p is less than alpha, we'll reject H naught. If p is greater than or equal to alpha, we do not reject H naught. So let's see what's going on here. So here's the key for you to remember how to find the p-value. If you remember this, you'll know what to do. Otherwise, you got to memorize, and trying to memorize this test and all the other tests to come is a little tougher. So if you get this concept, it's going to make life a lot easier for you. So if you're looking for p-value, you're looking for area, associated with test value. That's going to be true for every hypothesis test we do. That's what the p-value is. Okay, so what was our test value? Wasn't it negative 2.77? And what kind of test are we doing? Right tail, left tail, or two tail? We're doing left tail. So this time we're going to go back here to a z-value of negative 2.77, and we're going to find the area associated with the left tail. Okay, now, is area an inverse normal problem or a norm CDF problem? It's a norm CDF problem. So we're going to norm CDF negative 1E99 negative 2.77. Whatever that number is called the p-value. Whenever I do that on my calculator, I get 0.0028. Usually 3 or 4 decimal places is fine here. So there's your p. And so the question as to whether to reject or do not reject H naught is, this question, is P less than alpha? Well, P on this problem is 0.0028 and alpha was 0.05. Is 0.0028 less than alpha? Yes, it is. So guess what? We reject H naught. If you're a big picture person, what this 0.0028 really represents is that's the probability that we would have went out and got a p hat that we actually got. A p hat of, what was it, 438 that we had back up here in this formula. The probability of getting that, given the conditions that we started with, is only 0.0028, and yet we went out and got that. Only had 3 chances out of 1,000 of getting it. It's not very likely, is it? Okay. So we reject H naught, and obviously the conclusion then would be the same as before. There is sufficient evidence to show H1 that P is less than 0.05 at 0.05 at alpha equals 0.05 level of significance. That's the classical approach and the p-value approach.